Please open in your learning workbook to page 105 as we solve some problems involving the quotient rule for radicals. All right, now that we understand the quotient rule for radicals, we can use it to complete a problem. We will also need the product rule for radicals for this problem, so that's the reason why we learn the product rule first and the quotient rule second. Assume all variables represent positive real numbers. Our job is to simplify this expression, negative cube root of the fraction z to the fifth over 64x cubed. The first thing that I want to note about this problem is there's a negative outside the radical, which means my final answer is going to be negative. And I don't want to forget about that. So I'm going to go ahead and write my final answer right down here. I'm going to go ahead and put that negative sign in there so that I don't forget it as I go along with my solution. Okay. So the first thing I'm going to do to simplify this is I'm going to use the product rule for radicals. I apologize, the quotient rule for radicals. The quotient rule for radicals says if I have the nth root of a divided by the nth root of b, that can be rewritten as the nth root of the quotient a over b. Now, interestingly, for the problem that we have, what they've given us is the right side of the formula, one radical with a fraction underneath. And what we're going to do is use the rule from right to left and break this one radical into two radicals. So, first the minus sign, then my fraction bar. I'll have the cube root of z to the fifth for the numerator, and I'll have the cube root of 64x to the third down there in my denominator. Okay, now I'm going to see if I can simplify both of these radicals. Well, we know that a cube root of z to the fifth is just a cube root of z times z times z times z times z. And we also know that the cube root of 64x cubed could be written as 4 times 4 times 4 times x times x times x. These are both cube roots, so as we simplify, we're looking to make groups of 3. So here's a group of 3, here's a group of 3, here's a group of 3. Each group sends one representative out to multiply. So, for my numerator, a z comes out, and these stay inside. So I get z times the cube root of z squared. Here, a 4 comes out and an x comes out, so I get 4 times x. The only thing that I can really do here to simplify my answer further is remove this multiplication dot. So the answer is going to be negative z times the cube root of z squared over 4x. Okay, problem done. Let's look at another one. All right, this time we have the square root of x squared y to the fifth over 100. All right. Again, we notice that what we are given looks like the right-hand side of our quotient rule for radicals formula. So we're going to work from right to left, and we're going to break our one radical of a fraction into two radicals. The numerator gets its own square root. The denominator also gets its own square root. Now we begin to simplify. Now we could write the prime factorization of 100 in our attempt to simplify this, or we can just acknowledge that the square root of 100 is 10. Up top, we're going to write this as x, x, y, 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 y. And because this is a square root and the index is 2, we're going to make groups of 2 matching factors, pairs of matching factors. Each group sends one representative out to multiply. So outside we'll have an x, a y, and a y. And inside we'll have a y. And now we can put some of these things together a little bit, and we'll get x, y squared times the square root of y over 10. And that is our final answer for this problem.